So this video is about complex conjugates. So we've already said that a complex number is a number written in the form a plus bi, and the conjugate of a complex number is written as z with a bar over it, and that is a minus bi. Now, obviously, if the original complex number had a negative coefficient on the imaginary term, then this would be a positive coefficient on the imaginary term. And it's only ever the imaginary term that changes its sign when you're calculating a conjugate. So say, for example, I have a complex number, I'll call it Z1, and it is 3 plus 2i. Then its conjugate, which is Z bar, or Z conjugate, is 3 minus 2i. So there's some interesting effects then when you combine a complex number with its conjugate. So for example, if you add a complex number and its conjugate, well, what do you think is going to happen? Have a think about it, pause the video, then calculate it and see if you're correct. So we're going to have 3 plus 2i plus 3 minus 2i. And of course, the imaginary parts are going to cancel out and you're left with just 6 as your solution. Now, this is a good time to point out that any number, even if it looks like it's just real, can actually be written as a complex number. If you've got what appears to be just a real number, bear in mind that it actually does have an imaginary part, but we might call it 0i. We don't tend to actually write this an awful lot of the time, but it's just good to be aware of it. Okay, so as well as addition, we might have subtraction of a complex number and its conjugate. So again, have a think, make a prediction. What do you think will be the effect of this particular operation on the complex numbers? Then do the calculation, see if you were right, and play the video again. So we're going to have 3 plus 2i minus 3 minus 2i. So in this scenario then, we're going to have 3 plus 2i minus 3 plus 2i. And of course, the real parts are going to cancel out, leaving you with just 4i. Now, a lot of the time in questions, they'll tell you to write your answer in the form a plus bi. So if that happens, just make sure to represent your answer with 0 in the place of the real component. Okay, so that's addition and subtraction of complex numbers and their conjugates. So what's going to happen then in the case where we multiply a complex number by its conjugate? So I'm going to multiply Z1 by Z1 conjugate. So again, make a prediction and then do the calculation. And bear in mind, of course, that I squared is going to be minus 1 if you spot it in your calculation. Pause the video, do that, and then play again to see if you were right. Okay, so I've got Z1, which is 3 plus 2i, and I'm multiplying it by its conjugate, which is 3 minus 2i. Have a look at that now. What does that look like to you? It should look familiar in terms of algebra. And you might notice that it looks like the difference of two squares. So you can take that approach in terms of your expansion if you want, or you can multiply it out term by term. I'm going to multiply it out the quick way. And so that basically means that I've got 3 squared minus 2i squared. Just make sure that you're putting a bracket around that entire imaginary component. And so that is 9 minus 4i squared. But of course, the minute I see that I squared, well, I know that I squared is minus 1. So I'm going to substitute. So 9 minus 4 times minus 1, that's 9 plus 4. Oh, gone off the screen. 9 plus 4 equals to 13. So again, we can see there that by multiplying a complex number by its conjugate, we're going to end up in a scenario where we only really have a real component. And again, just for continuity there, of course, 13 is actually a complex number with just a 0 coefficient on the I. I'm just going to leave it written though as 13 in this case, which is generally what we do when we just get a real result. Okay? And it's important to note that conjugates are particularly required to deal with complex division, and we'll be looking at that in a subsequent video.